Here we come to A-Level Physics 2008 structured question 5. So here we have a toy which is connected by a string to the ceiling. The toy is equipped with a fan so that when the fan blows, the toy will be propelled forward, and as a result the toy will go through a circular motion, just go around and around. Part 1, you are required to draw all the force acting on the toy in the figure. So for the toy, of course, we have the gravitational attraction downwards, and also we have the fan giving a force backwards, so that the toy will be propelled forward. So we have a propelling force. And when the toy is going around, we would expect that there is some air resistance. So there is a dragging force that is pointing backwards. I would call it the air resistance. And not to forget that when the toy is attached to the string, there is a tension that pulls it to the hanging point, the anchor point on the ceiling. So let's take a look on the side. Okay, on the side, if we look at the toy on the side, we would have this, and so the toy would be acted on by mg in the tension like this. Part 2, write down two equations of motion of the toy. Hence show that the angle theta satisfy the equation. So now let's do it part by part. We have to write down two equations of motion of the toy. How can we write down two equations of motion? We can try to consider the circular motion. As a reminder, the toy is undergoing a circular motion about the center, so the toy is going at a circular path like this. So we can resolve the t into its horizontal component and vertical component respectively. What we know about is this angle is theta. So the vertical component will be t cosine theta, whereas the horizontal component will be t sine theta. As we know that the length of the string is L. So if we talk about the radius of the circle, it can be shown that the radius can be expressed at L sine theta. Okay, so now we have the vertical line, upward force balanced by downward force. And when we look at the horizontal line, we have t sine theta, this component, that provides the necessary centripetal force. So we can write down two equations of motion based on this. Firstly, let's look at the horizontal part. Horizontal part, t sine theta is equals to mv squared over r. Here we express r as L sine theta. So we have, simplifying the equation, t sine square theta is equals to mv squared over L. Okay, and the second equation, we have t cosine theta, balancing the weights. So we have two equations. And so now I am going to prove that this equation comes from these two equations. So we have equation 1 and 2. As a normal practice, we'll try to do equation 1 divided by equation 2 and see what we'll get. And because the t divided by t will be cancelled out, so what we have on the left hand side is sine square theta over cosine theta. On the right hand side, we'll have m and m cancel out, so we have v square over gl. Now, sine square theta, we don't want sine, so we would try to put this as 1 minus cosine square theta because of the identity here. Okay, we can do so. So now I am going to put in the numbers. What we have here is 1 minus cosine square theta over cosine theta is equals to v square. Look at the question. Some information are already given. V is equal to, L is equal to 0.8, and M equals to 0.1. So we will just put in the numbers. 2 square, G is taken to be 10, and L is 0.8. So on the right hand side, 2 square divided by 0.8 divided by 10, this will become 0.5. So we will try to exchange the side. With cosine theta go to the right, we will have on the right cosine theta, and also we want to divide the 0.5 to the left hand side. Divide 0.5, that means multiply by 2 So we have 2 minus 2 cosine square theta. So it's close. Finally, we shift the sides. So 2 cosine square theta minus cosine theta minus 2 equals 0. So the equation is proved. Part 3. It is said that if the output voltage of the battery inside the toy drops slightly, describe and explain its subsequent motion in terms of V, theta, and T. Okay, when the battery is flattening, first of all, we know that the propelling force will be decreased. The toy will move slower. When the toy moves slower, speed decreases. We have an equation about the conical pendulum. Tangent theta equals v squared over gr, so v decrease. And so tangent theta would decrease. Left hand side would decrease. So theta would also decrease. And also we have another equation, t cosine theta equals mg. As theta decrease, cosine theta will increase. Here be careful. When theta decreases, the value of cosine theta does not decrease, but it increases. So now right hand side mg, it is not changed. So if one thing on the left hand side increase, the other thing will decrease. Tension becomes smaller. And so, therefore, we know that the toy will perform circular motion along a smaller horizontal circle